Good morning, everyone. My name is Amrit Kumar, and I'm from Allclear. We build a Rollup-as-a-Service platform that allows people to deploy application-tailored rollups in a very easy and seamless way. Today, I'm not going to talk only about Allclear, but the idea is to kind of give a perspective of what, generally speaking, what Rollup-as-a-Service platform builders are doing today, and how it draws parallels from what exists in the Web2 world, in particular AWS. So if you look at, we have, I think over the last year or so, or 2 years or so, it's pretty much established by now that if you want to build monolithic chains in the way they exist today, including Ethereum mainnet today, it's not very scalable because they end up doing all the 3 main components of a blockchain, which is execution, consistent DA, and in some cases, settlement. And so, and that's kind of the reason why monolithic chains are moving execution out in particular, and will hopefully become the base chain for DA and settlement eventually. And so, and a really good thing that happens when execution moves out is that you are no longer limited by the limitations or the constraints of the base chain, which does DA and everything else. And that's why you will. We have seen over the last years or so several types of execution layers being built, which have different traits. So, for example, you could say, "Oh, I want an execution layer that relies on, let's say, fraud proofs, or that relies on validity proofs." You could imagine different types of runtimes because you are no longer bound by EVM. You could say, "I want a fancy WASM, or I want my own VM because I think it's really highly parallelizable or whatever." So you could experiment with all sorts of runtimes on this execution layer and have your base chain like Ethereum for your DA needs. You could imagine building execution layers for certain purposes or certain business ideas. So you could say, okay, I want a rollup or execution layer that serves a general purpose businesses, so something like Arbitrum, Optimism, ZK Sync, and others. Or you could say, oh, I want something that's very sector specific. So I want a DeFi execution layer where all the DeFi protocols or applications like Uniswap, Compound, Aave, and all that will sit at one place, and they could share all the liquidity. Or you could go even more degenerate, and you could say, I want a rollup for specific applications. So you could say, I want a rollup for my DYDX application, for example. Or you could also say, I want to build a very special type of rollup that is a transient. So I want this rollup to be very short-lived, and I will explain to you in a minute what the advantage of this is. But basically, what I'm trying to say is that you could have different purposes. These rollups can serve different purposes in different contexts. And of course, they can be in a layer 2 mode, or it could be in layer 3 mode, depending on where this DA sits. And as a result of execution moving out of the base chain, we have seen a ton of execution layers being built. Of course, the popular ones we all know, Arbitrum, Optimism, ZK Sync, and others, but different other ones are being built as well that focuses on different types of VMs, for example. Now, this creates some pain points for developers, because if you are thinking of building or using any of the existing rollups, it's very hard because there's no unified framework for you to pick and choose and decide to use a certain type of offering. Some of these rollups actually offer you SDKs as well, but many of them are actually very low level, which means that it's not very easy to go and pick some of these SDKs, and it can take quite a bit of time to go through all the heterogeneity that exists in the system because of that. And so the question that I would like to ask here is, can we get inspired with something that exists outside of Web3, which is AWS? For example, today, if you are building a startup or any company for that matter, most of your compute and storage needs is outsourced to AWS or some other cloud service provider. You do not go and the bare metal route where you go and buy hardware and host it yourself internally. So the idea is, can we learn from AWS? Because all you do with AWS is say, okay, I want a certain type of instance, for example, I don't know, T2 medium instance, and with certain operating system running on it and certain configurations, and AWS basically offers that for you, and you start deploying your application on that system. So it would be good to have something like this in the execution world, in the Web3 space, where you could say, I want a certain type of rollup, and I don't want to manage any of that infrastructure. Can you do that for me? And that's exactly what rollups today, Rollups-as-a-Service platforms offer today. And if you try to see what are the benefits that you would get if you had something like this, is one, it reduces a lot of cost, because imagine you being, let's say, a game developer, and you're thinking about building your own application-specific rollup. You'll have to go and find sequencers, or you have to run sequences yourself. You have to go and run RPC endpoints, explorers, and so on and so forth. And it starts to add up in terms of cost. It also slows you down because as a developer, application developer, you should be focused on building a good, fun, and engaging game, and should not be worried about how sequences work, and where should I host my RPC endpoint, how to handle the load that might come to this RPC endpoint. And so if you had someone else to kind of handle that, and by the way, Rollups kind of give you the security guarantee, so you don't have to worry about that, because in the end, if you have fraud proofs or validity proofs, everything would still be secure. So it saves a lot of money. It could save a lot of money. It could save a lot of years of developer resources, and it could actually scale with apps. So for example, if you're growing, let's say you started with an application with, let's say, 100 users, and at some point it grows to a certain number of users, then you can actually scale your application as well by spinning up different instances of your execution layer. But the thing is that we want to offer this in a not like AWS centralized fashion, but in a much more decentralized way. And the question is, can we do that? But let's look at the Rollup-as-a-Service as they exist today. And by the way, Altlayer or other service providers that are out there, they kind of offer in the same model today. So it's kind of a common framework in which all the Rollup-as-a-Service providers operate today. So basically, you have this RAS provider, which is kind of like a vendor. And you as a developer, you reach out to the vendor, you say, I want a certain type of rollup with a certain VM. I want to customize my rollup in certain ways. For example, I want to use my own gas token, or I want to increase my block gas limit because my game is fully on-chain and consumes a lot of gas. And you could do that, and then you kind of pay in some way. It could be a subscription cycle, it could be metric-based and whatnot. And you pay this RAS provider some sort of money to provide this service to you. So it's a very SaaS model, a very traditional Web 2 model. And this is kind of what we offer at the moment at Altlayer. So it allows, Altlayer has a RAS product which is actually live. So you could go to dashboard.technology, and you could go and deploy rollups from there. It takes about 2 minutes for this rollup to be fully functional, and you can use it for your application needs. As I said, there have been several benefits of RAS. It's low cost, it's fast to deploy, it encourages innovation and experimentation, and most importantly, it allows developers to focus on their core expertise. So as I mentioned earlier, game developers can go and focus on game development and do not have to worry about any of the node management and infrastructure management. And many of the RAS providers, and I would say most of them, depending on how you define them, they offer this no-code framework. So you do not have to deal with SDKs. You just go there and click a few buttons. Just in the same way you go and build websites today, you would go and build your own rollup today just by clicking and with some buttons and clicks. So with Altlayer, we offer two types of rollups. One that we call ephemeral rollups. So these are rollups that are disposable in nature. So imagine, for example, Yuga Labs, right? Yuga Labs did a mint event about a year ago. It was hugely hyped. They raised, I think, about $300 million from that land sale. This was about the other side, metaverse land sale. It was hugely hyped, but during the mint event, about $100 million, if I'm not wrong, was wasted in gas because there was a huge gas war-like situation. And then after that, Yuga Labs did a community vote where they asked the community to go and vote whether Yuga Labs should go and build an app chain for their entire project. And it was voted 49%. So 51% of people voted no, you should not go and build your own app chain, and 49% voted yes. And so you could see that there's a huge divide between whether you should go and build your own infrastructure and whether you should not. And one of the main reasons is that when you go and build your dedicated infrastructure, whether it be a rollup or an app chain, you kind of get siloed in some way. So imagine for an NFT project, you would issue your NFTs on that rollup, and then once the NFTs have been issued, well, there's nothing much to do on that rollup because the activity that comes from secondary trading is not that much. And so a good idea would be to have something like ephemeral rollups, because what you could do is you could spin up this rollup and you do your mint event on this rollup. So you basically sell your NFTs on this rollup. And once you have sold all your NFTs, once you're done with it, you will take this infrastructure down. See, all the node infrastructure, for example, sequencers and RPC endpoints and others will be taken down. And when that happens, all the assets for example, NFTs or ERC20 tokens or native Ether that exists there, will basically get bridged over and settled on the base chain on Ethereum. And so it gives you a very highly resource optimized way of having a rollup. And even if you don't like a long-term burden of having a rollup, you could have something like this, which is kind of very AWS style of some sort, where you scale the infrastructure. For example, in case of Amazon, when during the Christmas time, when there's a lot of buying activity that goes on Amazon, they scale up the infrastructure. And when that buying frenzy kind of slows down, you scale it down. And here in this model, you're scaling down to absolute zero. So you don't need that anymore, and you say bye-bye rollup. The second one is persistent rollup. So this is very classical to, let's say, something very similar to Optimism, Arbitrum, zk sync, but for your specific application. So it's very ideal for anything that's long-term, has a long-term horizon. When we started back in the day, there was no OP stack, there was no Arbitrum Orbit, so we had to build this entire stack for Flash rollups and persistent rollups from scratch. It's an optimistic rollup implementation, but now we are in the process of integrating external parties, external SDKs as well. So if you like OP stack, if you like Arbitrum Orbit, or if you like any of the zk ones, you would be able to go and deploy those rollup instances as well. I'll skip this because I mentioned earlier, you could do NFT sale on Flash layers, and when the NFTs are sold out, those NFTs go back on the base chain, and then you could enjoy all the liquidity benefits that the base chain could give you. So for example, if you had an app chain, if you issued your NFTs on the app chain, you're missing on the liquidity that is there on the OpenSea, but if the assets move back on Ethereum, then you can enjoy all the liquidity that OpenSea has. So it's ideal for anything that's event-driven, like airdrops. You could imagine games. For those who know, Dark Forest is a fully on-chain game, and they drive a ton of transactions because every single move that you make in the game is an on-chain transaction. It'd be good to have something like that on a Flash layer. And we actually hosted that a couple of times, and it did about 200K transactions a day every single time we hosted that. So it'd be ideal to have something that is very short-term driven, but drives a lot of transaction volume on something like a Flash layer. I'll skip this because, as I said, it's very classical rollup, but application specific. Now, so far, most of the RAS providers that exist today, again, including Altlayer, they are mostly kind of like AWS wrappers, where you have all these sequences, RPC endpoints, Explorer endpoints, and whatnot. They're all hosted on AWS. And you are basically presented a UI wrapper from where you can go and manage some of these instances. But remember, when I mentioned earlier, the initial goal was to kind of build something much more decentralized and permissionless system. But what we ended up becoming was mostly a wrapper around AWS. So can we do better than this? And we are trying to do this. We'll see how far we go. But the idea is, with what we call Altlayer 2.0, but the idea is to kind of make it much more open, decentralized, and convert that more like a protocol where you would say, okay, I love that you guys manage, you as a RAS provider manages my node and infrastructure, but what if I want to manage it myself, or if I want my community members to manage my sequences and RPC endpoints? Can you do that? That you won't be able to do if you operate like an AWS wrapper. So the idea is to kind of open that network and open that system in a way that anyone should be able to come and operate these sequences and other node infrastructure. So basically, on the top is how Altlayer operates today. And by the way, most, if not all, of the Rollup-as-a-Service providers operate today, which basically you have some sort of an SDK or a UI dashboard from where you deploy different types of rollups. Mostly today on Ethereum, but with some RAS providers, you can choose to settle or use different types of DA, for example, Celestia or EigenDA. But this schema is very much the same across most Rollup-as-a-Service providers today on the top. And what we're doing right now is kind of decentralizing it using something what we call a beacon layer. We are still deciding on the right term. But the idea is this network kind of acts like an interlayer between your rollup service or the vendor that you have on the front-end side and the back-end, let's say L1 or L2 that you want to deploy your rollup to. And this beacon layer acts as, for example, a shared sequencer. So for example, you could say, oh, I want 5 nodes, and then you could get this 5-node sequencer from this sequencer. So this beacon layer kind of orchestrates all of that for you. And so this is kind of how the beacon layer would basically sit. So you have the beacon, you come and make your request for a certain rollup through the beacon layer, and the beacon layer will basically help you orchestrate the rest of the infrastructure for you. I'll give an example of what this beacon layer can do in terms of decentralized sequencing. So imagine you as a user or a customer, you say, okay, I want a certain type of rollup, and you specify your demand or request in a certain format. I'm putting a JSON file here, where you say, okay, I want to be connected to Ethereum. I want to use a certain DLA like Celestia because I don't want to pay Ethereum's cost. I want a certain VM. I want it to be optimistic in nature and whatnot. And what's really interesting is the last two part, which is where you say, I want my sequences, I want two sequences, and I want these sequences, because you don't want random people to come and operate your sequence, otherwise there's no accountability. So you want these sequences to bring a certain amount of economic capital. So you could say, I want my sequences to bring a certain number of tokens, and it could be across different tokens. So you could say, I want people to stake from eigenlayer, and if you're staking through eigenlayer, you can come in, and if you're staking a minimum amount of eigenlayer, STETH through eigenlayer, then you're allowed to become a sequencer for my rollup. So you specify your requests here, and then sequencers come and register their interest for this rollup. So it's kind of like a marketplace where you match the rollup demands, the demands from rollup, people who want to have rollups and people who want to operate these rollups as sequences. So the sequencer will then deposit the required economic collateral and stake, and then the beacon layer. So let's say, for example, you requested, let's say, 2 sequences, and there's interest from, I don't know, 3 sequences to operate your rollup, and then there'll be some randomness that beacon layer picks up, and using that randomness, it selects the sequences based on randomness and some stake parameters, for example. So that's the decentralization part. So you could actually you move away from this AWS wrapper model to a much more open and decentralized model where the RAS vendor is not the only one allowed to operate the sequences, but anyone can potentially do that as well. You could also use beacon layer for different types of verification purposes. For example, you could say, okay, I want my, if you look at the rollups that exist today, most of them, especially optimistic rollups, many of them don't have fraud proofs. So basically, you're kind of trusting the sequencer in some way. And even if, in some cases, you do have fraud-proof implementations, it's not fully, it's kind of permissioned. So you cannot, as a person cannot go and participate in fraud-proofing and challenging yourself. So what you could do is you could build a kind of a decentralized verification network where you will have this beacon layer that sees and watches. It acts like a watchtower network of some sort, where it keeps a track of all the blocks that are being produced across these rollups. And we'll have to see how this scales over time. But it will keep track of some of these rollups and will check whether the sequencers are producing things correctly. And this way, you do not have to wait, for example, for a challenge period. And you could, for example, allow exit from those rollups to the base chain or other dApps if you have. And we are doing this with something that we call a proof of validity, which is basically kind of like a semi-light client of some sort, where you get a set of transactions and you get the last state that you track, and then you check whether the new state that is being proposed matches. If you had executed those transactions, then it wouldn't match the new state that the sequencer is proposing. So this could act as this middleware which verifies the state of different rollups, and then it would allow you to do quick withdrawals and better interoperability. And by the way, this also allows you to have, let's say, better, or I guess tiered finality, I would say. Because one thing is, today, most of the rollups that exist today, both ZK and Optimistic, they all operate with a single sequencer. I mean, there's no security issues with that, but there's liveness issues. And also, the thing is that many dApps today rely on these sequencers for fast confirmation. So basically, sequencers give you a receipt and say, look, I have sequenced your transactions in a block, and you do not have to wait for me to expose the data back on Ethereum. And you can, if you want, you could go and update your dApp state in the UI on the UI side. But if you had multiple sequencers, then it gives you slightly better guarantees than just a single sequencer. And also, it helps you with liveness. So if one of the sequencers were down, you would still have other sequencers to go and process your transactions. So one thing is that because you have multiple sequences, the guarantee that comes from this receipt that the sequencer gives you is much better than the receipt that you get from a single node sequencer. The second thing is because this beacon layer is verifying your blocks, rollup blocks, it also gives you kind of like a harder than soft finality. So it doesn't give you the finality that you get if the data actually is on Ethereum, but it gives you some finality that it's in between. So between the sequencer, between the time when the sequencer gives you the receipt and the time it takes for the sequencer to actually put the data back on Ethereum. And it gives you that middle ground in that way. So it gives you slightly harder than soft finality, but in the end, you are getting the finality guarantees from the base chain when the sequencer has posted the data back on Ethereum. So it helps you a little bit with that as well, and which allows you to have better interoperability and seamless interoperability if you wanted to have that. Very kind of wrapping up things, a network like Beacon Layer that acts as a middleware of some sort. It helps you with decentralized sequencing. So some of the issues that you see with, or you can imagine with centralized sequencing like censorship resistance, liveness issues that we have seen, I think, with several rollups already. You could imagine centralized sequences. I mean, at the moment, most of the centralized sequences are being operated by foundations themselves, so you don't have issues with rent extraction and MEV. But if you had centralized sequencer operating in a much more open world, this sequencer might be kind of doing rent extraction and exploiting MEV. So some of those issues go away because now you have a decentralized network to do that. And it also, as I mentioned earlier, because your network does verification, you can build much better interoperability protocols tapping into that. And you could also potentially use that for governance. So you could say, because all these rollups are kind of tied to one base beacon layer, so if you wanted to update any parameters, it could be easily applied to all the rollups that exist on that, on top of that beacon layer. Well, that's mostly it. Thank you very much for your attention. And if you have any questions, I'm here. You can ask me now. But if you want to learn more, please go to docs.altlayer.io. Thank you very much.
Does anyone have a question?
I bored you, didn't I? But anyway, if you're shy, I'll be around. If you have any questions, we can talk later. Yeah, go ahead.
Shout out to the Dark Forest people. So in terms of these flash rollups that you were talking about, when you settle to the main chain, does the entire transaction history also get preserved, and is it also easily, viewable because, a lot of history is useful for, plugging into machine learning and whatnot?
Yeah, because we offer this in an application-specific setting, so we let the person who commissions a flashlight decide on what they want to do with this data. So they could say, look, I want these data to go back on Ethereum. You could put that. If you want to put that on Celestia, you could do that as well. Or if you say, I'm fine with just hosting it on my, small DAC committee, you could do that. So we are giving that flexibility to them. But yeah, I mean, I agree that if you want the DA guarantees of Ethereum, you should put that on Ethereum. But we are leaving that up to the developer to decide where they want, and depending on their cost and what they can tolerate.
Okay, cool, thank you.
So thank you very much.
Thank you very much.
Thank you very much, everybody.